Great to have these guys with us again. Always interesting, always an interesting demo from Bill. So, Dave, I'm just going to hand over to you, and the floor is yours, sir.
Fantastic. Thank you, Graham, as always. Great to be back with the IWBC for another webinar. Thank you for attending, everybody. We appreciate your interest. Today, we're going to actually lead with the demo. Just a couple of slides up front, get right into a demo. I think you'll find it powerful on its face, the demo, and then we'll flip back into slides to discuss architecture and get into the Q&A. So today's topic is telco-grade agent-based automation for intent-based orchestration and autonomous networking. And I'm joined by my colleague, Bill Malik, who's our chief system architect. And many of you have probably seen him on our previous demos as well before. So quick background for those who are seeing us, EnterpriseWeb, for the first time and hearing about our telco solution for the first time. Let me give you a little bit of background. So EnterpriseWeb is, if we're going to put ourselves in a Gartner type, category, an AI-enabled no-code platform at its core. So our core product, EnterpriseWeb, is a no-code platform. Now, AI, there's probably now 1,000, if not thousands, of companies now claiming they're AI-enabled no-code platforms. I think we're a little bit different in the sense that we started off from day one being industrial-grade no-code. We weren't trying to do light citizen applications, for simple business apps where any material integration or customization required IT again. And then you'd sort of be half pregnant, right? You'd be sort of half code, half no code. And so nothing really, the needle didn't really move. EnterpriseWeb is, no code, no compromises, right? It's we're geared for the systems engineer, data scientist, solution architect to build out full-blown systems described in metadata, in particular in graphs. So you can see that those graph icons there. So we support intelligent business infrastructure, and I should add IoT applications. In EnterpriseWeb, now it's sort of funny, we've always been an agent-based platform. It's a very trendy thing to say, and a lot of people are sort of slapping that onto websites very quickly, just like they are saying they're all Gen AI powered. But EnterpriseWeb was born day one as an agent-based platform. 10 years ago, we were using agents to dynamically assemble and configure tasks into complex workflows and to call external federated elements. Just doing that deterministically using a graph. So the agents, so think of it this way, an agent is just a software-based actor that is using the graph for domain knowledge, right? So in the context of telecom, it's going to have a rich model of harmonized model of industry standards. And it's going to use that domain knowledge as well as real-time operational context, so state and telemetry, to interpret events, automate decisions, and optimize actions. So instead of just doing sort of agentic AI, which again is very trendy right now, which is mostly geared at very lightweight applications, once again, our agents are using the graph because they're taking actions deterministically. The agents can call out to LLMs, and you're going to see that in this. We're going to be using generative AI in this demo today. So we can call out to an LLM like we can call out to any other endpoint, and we can in fact call out to multiple LLMs. They could be large language models, small language models, domain-specific language models. They could be open source, they could be in the cloud, they could be on premise. It doesn't really matter. It's just another endpoint, just like we can call, a NAS, or we can call, a cloud, or anything else like that. So, but instead of the LLM being the center of the architecture, the graph is the center of the architecture. I think that's really important because we're really getting at the heart of the accuracy problem with Gen AI, the consistency problem, the hallucination problem, and let's not forget the cost and energy consumption problems that Gen AI has. And it gets better, but at no time does a generative AI become a database, right? You can improve accuracy, and accuracy will improve, but it never becomes deterministic, right? And if you want a 5.9 network, you probably want to ensure reliability and availability. So we have 22 awarded patents at this point. If you've been watching our demos previously, that number keeps on climbing over the years, which is nice. So we've got additional patents pending, but 22 US awarded patents. And actually underneath the hood, and I'm not going to go into that detail, maybe privately, some of you are interested, happy to have those conversations. But EnterpriseWeb is doing hypergraph-driven metaprogramming. And what that really means is that we're creating abstractions over domains, over complex distributed domains like in telecom, so that instead of working like everything's a snowflake and you do point-to-point integration and everything's siloed and stovepiped, you create a common model, and that common model supports global transparency, end-to-end automation, and virtually centralized policy control. We use a hypergraph because just think how complex the telco domain is, right? And if you think of graph databases, something like a Neo4j or a Tiger Graph or even Semantic Web, they're all, those are different, two different kinds of graph databases, but they are graph databases, right? They're meant for data, which means they're meant for graph analytics, graph recommendations, data science. A lot of those activities can be batched, not real time. Most of the time when you're using a conventional graph database, you have to pre-optimize your queries. So it's not a real-time evaluation. It's not real-time queries. They're pre-optimized. Then you have to manage all of those. Also, those databases tend to have a problem as your complexity scales. And now, again, think how complex the RAN is. Think how complex the 5G core is, or an EPC is, or et cetera, right? A router is, and all the properties, behaviors, dependencies, affinities, anti-affinities, and all the things, dependencies that surround it. Then you compose that, right? You'd like to compose those declaratively into a service. And now you have a bunch of network functions composed, each with their own properties, behaviors, and constraints, et cetera. And then you deploy that on some arbitrary diverse infrastructure, whether that's a private cloud or public cloud, maybe the edge. And that's a lot of complexity. In a graph database, the problem is those databases shard. They explode with something called the triples, and they shard, and what happens, they lose read-write latency. And if you want to do real-time automation, which is what motivates EnterpriseWeb, we're not just using graphs for analytics. We're using graphs for real-time intelligent automation. We're doing thousands of operations per second per transaction at scale. So we use a hypergraph because a hypergraph supports complex multidimensional relationships, complex multidimensional and conditional relationships. And then our agents can leverage that to understand the domain and understand to do root cause analysis, to support AI ops and generate remediation plans, as you're going to see. So EnterpriseWeb, our company is if you don't know us, is a telco virtualization and automation pioneer. We ran the first Etsy NFV proof of concept. We ran the first Etsy zero touch and network service management proof of concept. We won 6 consecutive TMF Catalyst Awards. Networks.ai is our telecom solution for intent-based end-to-end orchestration and autonomous networking. We've been blessed with a bunch of industry recognition, even most recently. So if you remember at MWC 23, nobody was talking about Gen AI, right? Nobody was talking about Gen AI at MWC 23. It was only a couple months later that people started to talk about it. But at MWC 23, we were meeting with Microsoft in Barcelona, and we were working with them to demonstrate, to develop a demo for the world's first presentation of telco-grade generative AI for intent-based orchestration. That demo was at the Big 5G event in Austin in 23 in May. It's been almost 18 plus months. Nobody's replicated that capability since. We won a Light Reading Award for that. We were a finalist for Fierce Network Innovation Awards for AI, and now we're a finalist in just this month for Most Innovative Networking Solution. And you're going to see that we work with an ecosystem. Our platform is wide open for open multi-vendor, multi-cloud, multi-domain networking. But we have a really nice ecosystem working with people like Dell, Intel, Red Hat, Fortinet, Keysight, a lot of players that I know many of you on the line will be very familiar with and work with them. Again, we don't tell telcos who to work with, but these are ecosystems that we go to market with. that we've had successful collaborations. Today, we're going to go into sort of this Networks.ai or telco product, and we're going to show you how Networks.ai sort of bridges what you know about generative AI, right? Everybody's very excited about generative AI. Of course, you had the DeepSeek announcement, and oh, look at this, it's as good as OpenAI. It's still only 90% accurate, right? And that's 90% accurate for basic or simple things. Every research study shows that the more complex the queries or prompts, and the more prompts you make, the more likelihood the accuracy degrades, right? And then you go into something like multi-agent, and now you have each agent potentially being 90% or less accurate. You have a real risk of what could be a cascading failure, like a failure from one agent passing to other agents. You don't want that. And then you could also even have a compounding problem where you actually have a failure that gets compounded. You get a piece of wrong information goes to the next agent who compounds that wrong information by being less accurate. So you really need to think this through. So in EnterpriseWeb, we're blending AI, not just LLMs, language models, but also good old conventional AI, ML, RL, analytics, and rules-based logic. And we can flexibly orchestrate AI using our domain knowledge and real-time operational context. So again, the graph is providing sort of the deterministic side. It's providing a strong, accurate, reliable, consistent, predictable, explainable, repeatable, actions. And it can then also use that graph knowledge and even real-time state and telemetry information as context for getting inferences from LLMs, AI, ML, and other forms of analytics. So we're bridging those two. And in telco, and in the demo you're going to see with EnterpriseWeb, you can literally talk to the network, and you're going to get autonomous networking. And of course, autonomous networking. Of course, you could have semi-autonomous, humans in the loop, or you could, of course, constrain it further and say that every action requires a human to approve it. But the reality is the networks are moving so fast. You need to be able to support autonomous networking. Whether you deploy that tomorrow or not is not the question. It's whether your technology, your platforms are future forward and are going to enable you to support that. So talking to the network, is essentially Networks.ai simplifying and automating NetDevOps. So you're going to see Bill's going to be able to do the demo. Developers are going to talk to the network to express their intent so they can design, deploy, and manage complex services with no code. And one of the exciting things you're going to see is that the way we've done it is we sync all of the sessions through the graph. So the graph maintains all session state in an asynchronous, event-driven kind of way, so that you can actually move between talking to the system through GenAI, a GenAI NLP interface, but you can also flip back into the graphic UI, pull down some values out of lists, drag things around. You could also then drop into the API, and no matter how you want to work as a developer, you go interactively between those three for what's most convenient to you. Because, the reality is some things are much more convenient for a developer to drop down into the API. Being able to, but the system is going to maintain your context. So if you're down at the level of the API, you can still talk to the network, and the network will be refreshed by your latest actions. On the autonomous networking side, once you design, deploy, and manage, the system's going to use the graph to interpret events, evaluate conditions, automate decisions, and optimize actions. So using the graph and the AI is sort of using like your left brain and your right brain together, right? You want the creative side of your brain, but you don't want the creative side of the brain by itself, right? You have a logical side of your brain that is rational and has models of the universe as you understand it, helps you get through the day, every day, unconsciously. And then, every once in a while, is it going to rain today? What's my guess? I look at the clouds and, oh yeah, I'm going to infer that it's going to rain. I'm going to take an umbrella. So you want a mix of that deterministic and probabilistic together. Now, you're going to see that we've been partnering with Dell, Intel, Red Hat strongly. We're going to actually be talking specifically about use cases that we benchmarked in the Intel labs, and we can go into those details. And you're going to see that we're covering the whole life cycle, day 0, day 1, day 2. We're going to literally go from showing you objects in a catalog to composing them into services, to generating deployment workflows and management plans, to dynamically instantiating the service along with observability and AI ops. And one of the great things I think that is super relevant is that our methods are a low token, low latency, energy efficient approach to optimizing LLM inference and accuracy. Because we have such rich domain knowledge and real-time operational context, we can work with a large language model in a very precise way. It was very interesting in the recent DeepSeek R1. I think everybody in the world's heard about that now. If you read that paper, they actually talk about when you want to do reasoning, it's much better to work with an LLM in a single shot within a very targeted manner. That's what EnterpriseWeb already does. You probably, many of you on the line who have worked or played with Gen AI are probably aware that people are using thousands, sometimes tens of thousands or hundreds of thousands of tokens per interactions, and then waiting seconds or 30 seconds, tens of seconds, or maybe even a minute to get a response. We're able to use generative AI. Throughout this demo, you're going to see it. We're using about 3 tokens per interaction, 3. And we might do a few round trips with the LLM to validate something. That might be 9, 12, 15 tokens total. That's 15 tokens versus maybe 15,000 tokens. Now, that's not only lower token use, lower resource consumption, lower energy consumption, it's lower latency. Because when you're throwing tens of thousands of tokens, remember that's per interaction. So if you have 1,000 people, tens of thousands of users, and they're all throwing that kind of load onto the system, you're going to start queuing and your latencies are going to go through the roof. By being low latency, we're sort of slipping in. It supports a lot of concurrency before we ever hit anything approaching queuing. So, I'm trying to move fast. It's not a lot of slides, but I want to give you guys some background and we can have a really rich discussion after the demo. The demo is going to move pretty quickly because Bill's going to do it with Gen AI, and he's not going to do it with any code. So you're going to see him do the whole life cycle in a few minutes, even with him talking to it. So this is the kind of use cases we were doing with Dell, Intel, Red Hat, our friends at KX, Keysight, IBM. For the purposes of the demos, we were using the Aether project, which is now part of the Linux Foundation, formerly part of ONF. That's a software-defined RAN and core. Fortinet, I'm sure you all know. Camaleo is an open source IMS, and we're using that for a VoNR, voice over new radio. This demo is going to be really the demo we're going to do today is going to be 5G core, but we benchmarked both 5G RAN and 5G core standalone use cases, and again we can discuss those things. Primarily, we tested a couple of different Dell servers. We tested the R760, which is a data center server. We also tested their XR8000, which is an edge server. On the R760 data center server, we were running on a 5th generation Intel Xeon processor with 2x64 cores, 2 terabytes of RAM, 10 terabytes of storage, and an Intel E810 Ethernet controller, a programmable NIC, because we wanted to use that for part of the optimizations and the AI ops we were doing. Now, that's a pretty loaded data center server, but it's still half the cost, if not less, than a GPU-based server. And it's got twice as long amortization period, right? Because CPUs have a 5-year amortization period, where GPUs have like a 2-year amortization period. So on the R7060, we were benchmarking in the domain of 2,000 concurrent 5G user sessions for 5G standalone secure IMS demo off one box, with the AI and the network workloads on the same box. On the XR400 edge server, that was a 4th generation Xeon processor with only 32 cores and 256 gigabytes of RAM. Much smaller edge server, we're still getting 400 concurrent user sessions on an edge box with AI and network workloads on the same box. So we can run over GPU and CPU. We're not biased. For us, it's always like logical. You'd want the lowest TCO. You'd want the most energy efficient. You'd want the most scalable, right? So, and again, sort of, I feel very validated with the latest work from DeepSeek, because now people are starting to say, wow, this could be much cheaper. It doesn't have to be brute force GPU. And again, nothing against NVIDIA. They make great products. We can dynamically schedule across CPU and GPU servers. But why spend more money? Why rip and replace infrastructure? Why try and port everything to a new programming language like CUDA? I mean, seriously? That's non-trivial. Now, if you're doing it, great. We'll support you there. But it's a bit of a long march. So I'm going to pass it to my colleague, Bill, now. I think you're going to pick it up from here, right?
Yep, I will. Just a moment here.
Let me stop sharing. Make sure I'm not blocking you.
Okay, now you should be able to see my screen now. Can you confirm?
Just to remind everybody, you can ask questions at any time during the webinar. So Bill will be happy, I'm sure, or Dave will be happy to pick up questions either in the chat box or if you raise your hand in the participants tab, we'll unmute you.
We're going to try and keep this part to 15-20 minutes, which should leave us a solid 15 minutes for Q&A. We're actually really inviting it. There were already some, as you know, Graham, there were some questions that came through in advance. And, so we hope to make it an interactive session and just, sort of provoke a lot of, discussion. So, Bill, if, be mindful, 15-20 minutes.
Will do. Okay, great to be talking to all of you again. So for the demo itself, this will be the actual network service that I'll stand up. And really, I'm going to be concentrating on showing you the kinds of capabilities that we have around, as David mentioned, two real areas here. The talking to the network piece, where you're going to literally see me talk to our system and ask for the elements that I want out of this catalog, ask for a template to fill them into, and have really a conversation with the system for it to guide me through constructing this service. And then, of course, the management and deployment and so on after. And then on the second side, you'll see in day 2 when our autonomous operations kick in. So this sort of the details of this use case, may be directly relevant to you, but you can imagine quickly how you might modify it to your own, onboard your own elements and so on. Service will be simple. As Dave had mentioned, it's really going to be showing you that kind of voice over new radio scenario. We just don't have a physical radio plugged in. I'm going to be using a 5G core that comes from the Aether project, as we've mentioned, and then also an open source IMS. Protecting those are going to be some of the Fortinet elements, next generation firewall, and so on. And then that's going to be deployed onto an SNO, so a single node OpenShift instance that has the kind of AI extensions that you've probably heard about recently. But basically, it's going to have hosting for LLMs, and in particular, we're going to use the IBM Granite model. And then what you're going to see is us effectively doing the kind of, almost a control and management plane over the top of these applications. So
Bill, I just want to make one quick point. There's we've tested on a wide variety of models. IBM Granite 3B most recently. Previously, we were working on Mixtral 7B, right, Bill?
Yes.
And then also GPT 3.5, GPT 4, Code Llama, etc. So we are what you would call multi-model generative AI. A single instance of EnterpriseWeb can connect and communicate with multiple different LLMs, whether they're in the cloud or on-premise or at the edge, doesn't matter to EnterpriseWeb. And so this way you can actually, to the extent that some telcos are actually specializing models for certain tasks, we can call those models in those scenarios and call others in other scenarios. And again, we feel like that's the reason why you really want that kind of architecture to support multi-model LLM. So you're not tightly coupling to one LLM. The industry is just moving too fast, as everybody can see, to invest so heavily in a single LLM. You're going to know, we didn't even say it, when this IBM Granite 3B model has not been trained. No training, no tuning. Everything is happening, all the context it's getting. So a generic off-the-shelf IBM Granite 3B, no training, no tuning. All it's getting is the context from our what we call our telecom ontology. And so, just think about that. Think about the efficiency. Think about how fast you can move things to market. If you can focus on managing your domain model independent of your LLMs and save all that money you spend on training, all the time it takes on training, and which is really generally model specific, when you'd really like to have a single source of truth that you could then repoint at one-to-many models that will help you evolve your solution over time, because things are just getting faster, cheaper, and more accurate. This is not a good time to tightly couple.
Yep. So for the demo itself, what I'm going to actually do is first I'll deploy the network service as we mentioned, and then I'll show you a quick simulation. Normally we would do it with things like Keysight and a much larger testing sort of scenario or harness, and you can see those kinds of things in our results of the test beds and so on and other work we've done. But for this demo itself, all I'm going to do is I'm going to flood the network with traffic and show you how, if you don't have AI ops turned on, you don't have our autonomous networking, how the system effectively becomes useless really quickly, right? Meaning literally a denial of service attack. As soon as you turn on our AI ops, you're going to see the immediate improvement, constant optimization, all those kinds of things. Really, you'll see it almost tangibly right on the screen. So just to kind of set things up for what you're going to see coming. As far as what the system does behind the scenes is, after I've had my conversation, it's going to put together day 1 and day 2 plans. It's basically going to take a generic template from our system, and it's going to populate it based on the service topology we had, the elements, policies that are related to it, and what have you. And it will stand up something like what you see here, and I won't bother to go into the detail here, but our system will quite literally generate and execute a deployment plan for day 1. And then for our actual day 2, it will go right through from standing up the observability framework and all of the different, configuring and programming the AI ML that's going to be connected to it and what have you, and then right through to actually even generating remediation plans. And again, all the details here are going to be based on the service topology that I'm going to create. So without further ado, I'm going to jump into the system here and show you what this looks like. So I have an instance of, as we mentioned, OCP AI deployed. On this case, it's actually local on my laptop. I have an instance of the EnterpriseWeb software deployed, and right out of the box, a small footprint, 50 meg footprint to deploy. You get the entire telecom ontology and all of the connections you need to start running Gen AI right out of the box. So as Dave mentioned, I didn't have to train an LLM. I just had to point this at Granite in this case, so that I'd be able to work with it as a sort of an LLM that's backing the conversations I'm going to have and the autonomous networking you'll see later. So I just want to do
a little detail I want to throw in there, Bill, is in the Intel labs, we were able to demonstrate a push button deployment to either the R760 data center server with the Xeon 5 or the Dell XR8000 edge server with Xeon 4. That's deploying the LM, deploying OpenShift itself, deploying EnterpriseWeb, and deploying all the other elements of the solution in 3 hours. Effectively push button. And of course, of that 3-hour time, almost all of that time was deploying the LM and then the OpenShift itself, and the elements and EnterpriseWeb deploy very quickly. But we're doing everything to make this operationally efficient, operationally scalable.
So what you see here is the UI, and as David mentioned, everything that you're seeing in the UI is round-tripped through our other interfaces as well. An API, which you won't see me use here, but you can do absolutely everything that you see me do through the UI or Gen AI, through those interfaces, and even more if you're so inclined. You also have a Gen AI assistant that's basically following you around here. So you can see there's little cues here in the bottom right corner. It's aware of my context. So as I switch here, you'll see obviously different options based on the context of where I am. And this is going to follow me all through the system when I'm working in an object. Different kinds of actions might be appropriate, what have you. But you're going to see me work interchangeably with it. So I'll invoke it at some points. I'll say some of those commands. You'll see me go back and forth. And you'll see it really is an accelerator for us to be able to use the power of our graph that's behind this. Now, what you're seeing right now, though, when I'm logged in, I'm playing the role of a service designer, right, or a service architect. We have different modules for doing things like modeling the graph itself or onboarding solution elements, the kind that you see in this catalog. So it's all divide it up by your roles and so on, and security on every click. There's a lot of good features here, but most of that relates to my context. What's the security of what I can do in the environment, whether I'm logged in through an API or what have you. So you're going to see me exploit a catalog that's already been onboarded of solution elements. And adding one of these is a very simple kind of process. And again, you can even have Gen AI talk you through it. But I can basically say if I'm a vendor or I'm just someone who's taking a vendor's product and I want to onboard something like Camilio, which is a open source IMS, all I did was I uploaded into the system a tar file and a mop, and the system took that as its inputs, mapped it, and started to look at the type system, looked at filling or auto-filling properties, generating interfaces and behaviors around this object so that I could work with it, basically through Gen AI or through our platform in general. If I if I drive into any one of these elements that's in the catalog, what you get is a full kind of case around it, security, audit, all those kinds of things you want, versioning. But what's most important here is that it mapped each one of these elements to that graph. And I won't spend a lot of time here, but literally anywhere in our system, you can drive into what the system is doing behind the scenes if you want to see what those graphs look like. And they're instructive just to give you an idea of what powers both the conversations, the autonomous networking, etc. It's this kind of a graph model that's behind it. So what I'm looking at here is something that comes in, and I'll start. This is an application called an IMS. Right. If you start to look at the kind of domain about elements, you'll see things that you're probably familiar with: the component models, web, RTC, etc., what have you. Application models for user plane, charging functions, etc. These are the kinds of things that take us away from the kind of concrete things that you might see in some places like an Etsy that just basically do the sort of basic LCM of start and stop. And you'll see, of course, we support those elements, but it's these application models that are living sort of at layer 7 that allow us to do all the real, interesting things with wiring our elements together, being able to put this particular IMS in the context of either, your sort of 5G complete, standalone kind of environment, or something that might have some 4G elements in it, right? So this supports really all of the kinds of high-level mapping that we want, and the ability for the system to drill down and really configure this thing, optimize it for the actual hardware you're going to deploy it on, the services you're going to use it in, or generate that you saw before.
And we can, in addition to taking mop and tar files, we work with CIQs as well. I mean, we can import like multi-tab spreadsheets and transform them right into our graph. So with the great advantage of creating a common abstraction across all those, essentially being able to transition from your current practices, often when you're using spreadsheets and other things like that, being able to use those as inputs, be able to bring them into the common model where you can now work with them as metadata. It's just going to support, creates, essentially a dependency graph, right? Now it's going to not only support the onboarding, but it's going to be providing the domain semantics and metadata for every aspect of the lifecycle, from composition to deployment to management to troubleshooting, right? So it's the graph is very rich.
Yep. So now you're going to see me exploit that graph. I'm going to have a conversation now with the system to do that composition and design of my network service, and then you'll see me manage it after. So let's go ahead and do that. I'm just going to turn up my volume so you can hear it here, because I'm literally having a conversation. Show me a list of service templates.
Working on it.
Show me the graph of a standalone 5G core.
Working on it.
Add an IMS core.
Working on it.
Add a next-gen firewall.
Working on it.
Add a virtual router.
Working on it.
Can I compose this?
Yes, all required elements are in the catalog.
Execute command compose network service template.
To do this, I will create a new network service template named Secure 5G Core with IMS. Add an instance of EtherStack for core. Add an instance of FortiGate to provide the next-gen firewall. Add an instance of Camelio to provide the IMS. Add an instance of Vios to provide the virtual router and add EnterpriseWeb for core management. Would you like me to proceed?
Yes.
Okay, working on it.
Okay, so what the system did was it put together a minimum viable service for me based on that conversation that you just saw me have. If there were other, things like other options in our catalog, it would literally prompt me along the way to pick the ones that were most applicable to my sort of intent. And you saw that was an example of the kind of human in the loop that we can enable. So it did a pretty good job, and it does right out of our catalog because it's leveraging that graph knowledge that it had, so it understands what it should look like in terms of the connectivity between them and how to sort of basic configuration of each of the elements. In this kind of a case, even going so far as to do things like figuring out that having a next-gen firewall means that there's the potential for me to actually secure the control plane, which is probably what I want, and so that's why it's defaulting it. But I always have that option of driving down as deep as I want. You can do that into the service chain, all kinds of policies. You can even get down into affinities, etc. But what's important is that it put together this minimum viable service for me. It's completely infrastructure independent at this point. It's actually going to, you could repoint it to a specific target if you want, and same thing, you can configure slice kind of characteristics about this thing because it'll support that full kind of the full breadth of what you have in a standalone 5G. Which is great. But the thing is, it will be bound at the point of ordering. So I have something that's right now is generic. I can point it at OpenShift, which I am going to do in a little while, but it can just as easily be pointed at things like a cloud, and we'll be able to, the system will figure out how to work with those APIs rather than directly with OpenShift and what have you. But there's, a lot of reuse that comes out of one of these service templates. In addition
so just to summarize, Bill, so it's infrastructure independent. So we were able to create service models, right? They're independent of their host, compute and network environment. So they get bound to a network, right? And the system will essentially even filter only when you're looking to deploy this service. It'll filter down to available and applicable networks that could support some of the resource requirements and constraints of that service, right?
Exactly. And so, in addition to, sorry, did I cut you off?
No.
Okay. Oh, it's my apologies. So in addition to actually standing up the service itself, we're also doing things like mapping properties and so on. We talked about this a little bit on the onboarding, but in this kind of a case, it's just associating a couple of policies that you might want for the day two. And again, you can expand this as much as you want coming out of the catalog and adding standard terms. But out of the box, the system has already put together a pretty good service composition, and it's generated for me two plans. Right, one is going to be effectively day one and day two. So a deployment plan and a management plan. Now, each one of these we talked about it briefly when I showed you the slides, but I was talking about the fact that our system would take these high-level templates and then it would effectively customize them based on the service topology. So what you see here is our state chart, right? So it represents a data flow process. This is how we do all of our workflows or processes and modeling in our system. It's a set of event-driven tasks that are staged or effectively in a set of stages that the stages don't really differ in almost all deployments. You're going to have some element of establishing an environment, deploying a service and configuring it, but then really all of the tasks below that are based on the elements that you'd selected, policies that are at play and so on in the system. So it goes in and it creates these. And what's important about these tasks actually is that there's no sort of static fixed workflow between them. The kind of BPMN that might fill a wall. What you get is at a glance kind of description of looking at the high level tasks that you want. You get a very dynamic flow between them. So what you're doing is whenever an event comes in, the system is looking at the real-time context, figuring out where I am in this process, and not just what tasks to go to, but how many, right? This thing is meant to be run massively in parallel. And if I looked at it as a kind of simulation, I would see that, right? I would see that after we've bound our interface and our operators, we updated our DNS, well, then we're into a place where we're instantiating everything in parallel as we kind of want to, and leveraging the best of cloud native technologies. So you get something that's going to be flexible, easy, and if you wanted to manipulate this, it's very easy to add another task into your workflow for your customized, sort of operations. And you can drill down as much as you want, but from a high level, this this is the way I want to describe it. And I can go down and parameterize these as much as I might want. In the same way that we're building a deployment plan, the system is also generating a management plan. You'll see it looks almost the same. Details differ a little bit here, but it actually covers everything from standing up the observation framework that you're going to need, because it's going to be different based on your elements, right? So it might be different probes or different configurations of a Prometheus or what have you that's going to stream the telemetry. The system will take care of all of that, and then even give me opportunities to, modify how I'm going to work with the LLM if there's a special one that I want to invoke in the autonomous networking. So it becomes something that's, it's not a buried black box that you might find in some other environment. All of the logic here is going to be traceable, and not only fast when we work with the LLM, but you get a full trace and transparency of what actually happened when you interact with it. So a couple of plans that will be used in a moment. Also, just to sort of round it out, we also generated a set of standards-based interfaces people you're used to, even things like the Kamar interfaces that are coming from the Linux Foundation now, so that I can order instances of this thing literally through standards-based their gateway, and again without. The important part is none of these aren't stubs. I don't have to write Python or anything like that. We talked about no code systems giving me an implementation of these APIs behind the scenes as well, so I can work with this in an edge cloud context if I want to, once it's in my catalog. Now, we also extend this out to test DevOps, right? So, and you'll notice as I've been flipping around, you've probably seen that I have different Gen AI operations I can invoke at any time. But it just an important point of this is that we can also attach this to your test DevOps frameworks, right? So if you have things like testing tools that you need before it goes into the catalog, we can enforce those kinds of workflows here, and you'll see that in some of our other demos, where it basically has to meet a standard before it goes into your catalog and can be ordered. In addition to facilitating that kind of automation, we also generate a whole bunch of artifacts, almost anything you might want to work with this, including OpenShift operators. So you can onboard this component, do all the composition in our system, and even export basically a compiled operator if you want to use it sort of for independent management. So
just real quick, we're going to do a demonstration on this in next week's AT&T's workshop hosted by IWPC. There's one specifically on the use of AI ML in test ops. And we're going to be doing a demo there and that's going to feature AWS and Rabaka, some work we did with Tech Mahindra to automate the deployment of tests to spot instances, and to distribute that out maybe to hundreds of spot instances, manage their state. If a spot instance goes down or goes away, we restart it somewhere else based on the last known state. So we'll get into detail in the next week's session.
Yes, you can see that then, but that will tie in directly to what we're doing here. So I'm just going to actually push this into my catalog, and then, sorry, that's just a second. So what I'm going to do now is just deploy an instance of this. It's now in my catalog after we went through that process. I'm going to bind it to a specific host. It just happens to be the one that's my local instance here. Now what we're going to see is that the system is deploying now. It's adding it to my inventory, and if I want to look at it in terms of services or slices, etc., I have all kinds of views to get to these things. But what we're seeing is that the system right now is just in its allocation stage. This will be deployed and ready to go in no time. But you'll also notice that there's this little link here about viewing a dashboard, right? So what's that about? Well, and you can see actually it's healthy now. So there's a couple of ways we could look at this quickly, but just to sort of fill it out is that we now have a full life cycle history of this object, right? So we went through building that template, but now we've deployed it. So we can actually get a full look at, and you're going to see this kind of trace capability that we have. Right now, I'm just showing you, basically, I'm showing you one event that occurred against this service, it being instantiated, deployed, and configured, right? That it was ordered through a web portal. I can see the full trace history that a developer might want, right down to what subnets were ordered. I can go to whatever granularity I want, and I can also filter this, which is important to that graph earlier. If I care about things that are related to the core, for instance, in a particular element like Aether, I can zoom in on them right away and get that information that I might want. So it's sort of the power of the graph to help me make use of this full level of trace, get the information I need quickly if I need to debug or even just audit this thing. And you're going to see this applies in a couple of minutes. We're going to get into the actual NLP side of it, or sorry, the autonomous networking side. And you'll see that for every event that autonomous networking does, the same exact kind of a level of trace, it's just going to be interacting with slightly different elements, things like AI models and so on. But you get a full trace of every event. Right now, there's only been the one. Other nice features, like I get a graph model. It shows me where this thing is deployed, how slices might be allocated, health of all the individual components with click-throughs, those kinds of things I might want. And we talked about observability, so I'm just going to show this to you quickly. System built a bunch of dashboards as well for me to actually look at this particular service. So you can see right now there's no latency, there's no traffic. There's a very low power consumption, but this is what the AI ops is going to actually be based off of. For these levels that you're seeing here, this is what the system, right now, everything is fine. It's under SLAs and all of that. I'm going to show you now, and I mentioned it earlier, but just a reminder, the policies for AI ops are turned off, meaning it's going to throw events, observability is there, you're going to see how the system reacts in the face of a whole ton of traffic, but you're going to get to actually witness what the system would do without this kind of continuous adjustment, meaning we've got a service that's deployed, suddenly things spike. Well, you'll see the power of AI ops in a before and after kind of way. So first, I'm just going to show you that I can use this service. So I'm going to place a quick call over it so that we can get the full effect here. So here we go. Place a call over this service. Mute everything so you don't hear me. Okay, so that should be good. And you should be able to see me now. Okay, so cool. So we're using the service. Everything's fine. Our levels are all okay. What I'm going to do now is I'm going to simulate a bunch of traffic. So I'm just going to use a very crude simulation here to send a bunch of traffic here to see what happens to the system at that point.
Attention, poor performance detected for a service under management.
Okay, so obviously I don't have enough bandwidth to continue the call right now. If I look back inside the UI here, I can see that all the levels are being actually thrown over to EnterpriseWeb, and obviously we're in the red for things like power consumption and latency. So obviously we have to correct that problem. So the system actually went ahead and looked at and started to deduce what the issues might be. So this is a bit of human in the loop, but really what's telling me is effectively to activate the autonomous networking, right? So what I'll do is I'll take its suggestion and we'll see how that helps us. Activate AI Ops Day 2 policies.
Day 2 policies activated.
So you can see as far as the system goes, it's back to healthy. If I jump back into my dashboards, yeah, you can see the levels have all come back down to where they should be. And if I go back to my phone, okay, so anyway, services restored. So as far as the system is concerned, and if I had autonomous networking on, we would have even seen a blip there, but we would have seen the results, which is that if I look at the life cycle of this, you'll notice that there's no longer just that one order, right? There's continuous operations here, scaling, healing, etc., however they're categorized, but there's autonomous networking going on now continuously for this service. You can even see that Gen AI response where it realized I should activate the policies, right? So everything's, again, captured inside the system. It's all good. If I want to look at it from the sort of event streaming kind of point of view, which is where it gets interesting, I can see there's actually a little dashboard here that's showing me the events as they occur. And if you notice when it's refreshing here, these events are continuous. This is a sort of micro adjustment to keep the optimizations down. You can see the impacts, what it did to, improve latency and power. And you can even see the total LLM tokens that were involved behind the scenes on this. 5, 3, they're all really small here. And if I go into any one of these, right, I can see that lower level detail again, right from the system identifying what the scope of this was going to be, the particular instance, what have you, right down to even what it actually did in terms of identifying what the problem was. A latency threshold within a certain threshold. Again, I'm not going to go into the low level detail here, but there's a recommendation for scaling out that was suggested. It passes it through the LLM, and I can even see a low level breakdown right here. 4 input tokens, 3 output tokens for it to help me make that kind of an inference about as far as what should be adjusted and then what that translated into. I mean, and you can see it's under a second for the actual interaction itself. That's pretty powerful and pretty quick. And you can see that it even included adjusting a P4 policy right down to, what to do in terms of not just adjusting a service element, but even infrastructure changes. And the transparency here is actually, kind of amazing. I can even go right down to what the config change was, so I can see what it was before. and then an after, of course, and then even just a diff, right? And the system doesn't keep any weight on these things. This is just, it will keep a very small popcorn trail of effectively what the event was and what change was, and then you get this kind of low-level transparency built, or how to say it, rehydrated out of our graph. And so it gives you that full story of what the system's doing to maintain those optimizations. And I could look at this, again, you look at it as far as I want, but even the NLP operations that we had earlier are all same exact thing. They're all logged here in the system, so I can see them in a transparent way. So I can actually see what the conversation was when I decided, say, that I wanted a router, right? I can drill into the detail on that and see, what my context was. I was in the graph model, again, low token use, and what the actual results were. So again, it's that same kind of a policy that's using Gen AI assets, so things like LLMs and AI models, in this case our own predictive analytics, to give you efficient operations and leverage that graph to do the kinds of outcomes.
Hey, Bill, we're running a little long now, and we want some Q&A.
So thank you very much.
Thanks for the demo. So I still see that a good deal of people on the line here. So if anybody has any questions, I know there were some questions that were submitted in advance. So Graham, if you want to read them out, or Bill will respond to those.
Yeah, let me just do that quickly.
And if anybody has any other questions, I can go into some other slides if anybody's interested. We have different views of this, going deeper into the architecture, deeper into the deployment. So.
Yeah, just put yourself on mute, Dave. Because I was coming out, and good. So what it says here is observability and visibility will be key to oversee, to catch and rectify incorrect rules, intent-based automation, among others. How are you addressing this need? Is that something you can relate to?
Yeah, I actually think Bill did a great job of showing that. I think what we're showing is that the graph provides, the all full transparency end to end across the full scope of that service, the slice, the services, the functions, the hardware and devices. You could drill down into the lowest level transaction detail and into the individual discrete events and what the system actually did. So I totally agree with whoever gave that submitted the question. It's fundamental. And the problem is, in the history of telco, and this is not an attack, it's just the way it evolved, right? Is that everything was so siloed, and so not only siloed by domain, that's just one problem, right? So you got RAN core transport, as if that was the only domains. And then you also have the stovepipe, right? You have some people who do AI ops, right? You have some people that do service management. You have some people that do application performance management. You have some people who do aspects of programmable networking for the RAN. Some people do aspects of programmable networking for the core. Some people do it for the transport. And the problem is, because those things are all done discreetly, you have no visibility across the end-to-end. And if you want to optimize a slice or service, whether that's optimizing it manually or troubleshooting it manually or doing it full-blown autonomously, you need that visibility. So at the minimum, EnterpriseWeb is providing that. At the beginning of the call, when I was setting up EnterpriseWeb, we talked about graphs, the role of abstraction, to provide high-level views, a common model, shared tools, across the domains, so that you can truly optimize network performance. Most recently, people have been really bringing this up a lot. I know the best example was after the TIP Fuse event. That was, I think, November, December timeframe. A lot of people were coming back, and there was interviews from the event, plus as well as after, and almost all the CTOs were coming back and saying, we need a horizontal architecture. We need dynamic configurability. Well, you're not going to get a horizontal architecture, and you're not going to get dynamic configurability without a high-level abstraction across the problem space. And if you think about it, that's what the name EnterpriseWeb, when we conceived the company, founded the company, the whole notion was you'd like an enterprise web to be able to see the people, the information, the capabilities right? The systems, the databases, the services, all the endpoints that you're connecting. You'd like a common view, a common catalog, a common inventory. Now, keep in mind, even though I'm saying that could be drawing on federated sources. We recognize that people have existing inventories. We understand that people aggregate data in specific ways. We're doing this inside tier ones. We're familiar with that, so we could plug in those sources, but we're giving them that one abstraction to take all those things. So it allows you don't have to burn down your brownfields. You can lay the abstraction on top, connect to the systems below, whether that's NAS or anything else. Use the existing, like I mentioned earlier before, you got your CIQ, you might have Ansible playbooks, whatever, that's okay. We'll work in a federated basis, but you're still going to gain value from having that common visibility end to end, east to west, north to south.
Okay. Hey, Dave, there's another one here, and this is beyond me, but it's asking how you account for ontological drift. Yeah, you're on mute now, Dave. Sorry, you muted yourself, and then.
Okay, sorry about that. So the question was ontological drift. So there's a sort of a data scientist or a modeler on there, or a solution architect on here that sort of is familiar with ontologies. No, so ontologies have, like any other, just like Gen AI models have issues. Ontologies have in models, any kind of human model has issues because humans created it, and humans have to maintain it. Of course, we can do that now in a semi-autonomous way, working with AI as well. But to answer the question, ontological drift, that comes in a couple of different formats. You can almost think of that and back that up to essentially say change history, right? To make that accessible to everybody. How do we manage change history in the graph when all of your standard industries, standards bodies are evolving the standards at different time cycles, right? How do you manage that? Well, one level is that we do it is that we model every object in Enterprise Web is what you call immutable. So it's a graph object, but it's an immutable graph object. So we keep the history of every graph object. So let's just take Etsy. Etsy is a source of standards. We have an object that's called Etsy. We have an object that's called, NFV or other aspects of their standards, and that drills all the way down. And for every standard, we'll have every version of that standard. And the way we implement that is so lightweight, it doesn't really cost the system anything. The demo you just saw, the whole demo with the model, our whole solution is 50 megabytes. So the whole model is version controlled. Every source of provenance for the ontology is version controlled. Every domain object is version controlled. And this way, think of it, you could be doing 4G, 5G, and maybe down the road 6G in a hybrid network. We know this happens today with 4G and 5G, right? And everybody wants to get to 4G standalone, 5G standalone, but they're still doing some 4G in there. So you need to be able to support that. It means you have a mix of standards. Also, your domain objects, your routers and your RANs and your cores, they're evolving and getting updated as well. You might have many instances of many versions with different configurations of the same router from the same vendor. And Enterprise Web will maintain all of that complexity. So the short answer is we maintain that really well. That's one of the properties of being a hypergraph, because a normal graph, like a graph database does, that's super hard to do. Again, it would explode the graph database. It would slow it down further. And again, reinforce the fact that you're doing pre-optimized queries all over the place. Enterprise Web maintains everything real time. We're version controlling everything in real time. And we're able to walk between different versions of objects, standards, rules, etc. That person might want a longer conversation, and we'd be happy to do that.
Great. Okay. Hey, Dave, listen, we're just about out of time. So if you want to just close off with any closing remarks, that would be great.
Yeah, no problem. Well, first, thank you for everybody on the line. If you want to throw in a last minute question, feel free to do that. Otherwise, the deck's going to be available. Eventually, the video is going to be made available. And you can always reach out to, I'm Dave at EnterpriseWeb.com. Bill is Bill at EnterpriseWeb.com. So that's pretty easy. You can reach out to us for follow-up. Graham, Tom, Debbie, everyone on the IWPC team. Thank you.
Great. Hey, and thank you, Bill. Thanks, Dave. Just a reminder, these guys are going to be involved next week on the AT&T session as well. So if you're listening next week, you'll probably get a chance to follow up. So, and Dave, thanks very much. We'll make sure you get connected through with any of the guys that are on the call.
Thank you, everybody.
Thanks a lot. Thanks.